Section 1.4, Measuring Angles. The definition of an angle is that it is formed by two rays with the same endpoint. The two rays act as the sides of the angle, and the endpoint is known as the vertex. In order to name an angle, you can do so by naming it with the angle symbol and then the vertex letter. You can also use a point on each of the rays and the vertex in the middle. So the angle symbol, in this case, BAC, or angle CAB. The order is important. The vertex has to be in between the two ray points. All right, so the order matters here. Or you can name an angle by a single letter, or a single number, sorry. So in this case, angle 1. And when they say angle 1, they're not talking about the degree of the angle. It's just an undesignated number that is referencing that angle itself. So this is our diagram of angle BAC, angle A, angle 1, angle CAB. Naming an angle uses 3 points. The vertex must go in the middle, so don't forget that. When you're naming it using 3 points, the vertex has to go in the middle. And when you talk about angles, you have the interior and the exterior of the angle. The protractor postulate, simply stating here that the legs of your, or the sides of your angle can correspond to different parts of the protractor in order for you to determine the measure of the angle created by the two sides. So consider OB and a point A on the side of OB. Every ray of the form OA can be paired to one and only one real number from 0 to 180. So what they're saying is, let's say you're using this side here as OB. Somewhere there's going to be an OA ray that's going to have a measurement for our angle between 0 and 180. That's it. All right, so here we're going to use a protractor real quick to find the measures of the three angles and then classify them. And so we're going to wait to classify them until after we learn the types of angles. All right, so here, MLN. So M, L, and N is here. Well, I know this is not a very big angle, so I'm not going to use these large numbers inside. I'm going to start at 0, and I'm going to go 1, 10, 20, 30, 40, 50, 60. So MLN has a measurement of 60 degrees. Then I repeat this process with NLQ. So NLQ. Well, my base here, so I'm going to go from 0 all the way up to 120. So NLQ has a measurement of 120 degrees. But sometimes you deal with an angle that on a protractor that's not perfectly set at the bottom, or you have one that sits perfectly across the bottom. So you have to make sure you're using your problem solving and critical thinking skills to find the measurement. MLQ should be pretty straightforward here. No matter what side you start on, this is clearly a 180 degree angle. So MLN is 60 degrees, NLQ is 120, and MLQ is 180. Here we have the 4 types of angles. These should be fairly familiar. You learned them in middle school, and you've encountered them quite a bit throughout your mathematics career. You've got an acute angle, which is when you have an angle with a measure less than 90, but greater than 0. You have a right angle, where you have an angle measure that is equal to 90. An obtuse angle, where your angle measure is greater than 90, but less than 180. And then a straight angle is when you have an angle measure equal to 180. An important piece of information here, angles with the same measure are congruent. This means that if the measure of angle A equals the measure of angle B, then angle A and angle B must be congruent. So here we have the angle addition postulate. It's a lot like the segment addition, but involving angles in this case. So for the first situation, if B lies in the interior of angle AXD, then we know that angle AXB plus angle BXD has to be equal to the measure of the entire angle AXD, since it's the two parts put together to make one whole angle. Situation 2, very similar. If AXD is a straight angle, meaning it adds up to 180, Then if you take the part angle AXB plus the part angle BXD and add them together, it should equal 180 because the entire angle itself is a straight angle, which means it equals 180. Here we want to talk about another way to name GXH. Well, we could just flip around the letters, right? Angle HXG. Or notice that there's a 1 in the corner of the angle, so we could also name it angle 1. We're not going to be able to name this angle X because X is shared by multiple angles, and that would just get confusing. All right, so now they want us to name a straight angle, and there's actually a couple of them here. We've got angle FXI, or we could say angle GXJ. Either one will work. And the last question here says, if FXH equals 130 and IXJ equals 49, find the measure of GXH and IXH. So let's go ahead and list what we know. FXH, which is this whole measurement here, is 130. IXJ is 49. They want us to find the measure of GHX and the measure of IXH. Well, keep in mind that FXI is a straight angle. So if part of it is already 130, in order to get to 180, IXH must be the remaining piece from the 180. Well, 130 taken away from 180 gives us 50. So IXH must be 50 degrees. All right, now GXH. GXH is a part of the 130, but it's just this upper region here. Well, something you should know about angles is that when they're designated with these arc symbols like this, it's a lot like line congruence where we put the dashes. This means that these two angles are congruent. So if this angle here is 49, so is this angle here. So to find the measure of GHH or GXH, all we need to do is take 130 minus 49, and we should get that GXH is 81 degrees. All right. In the next problem, we've got angle OZQ is 150, angle OZP is 6x minus 5, and angle PZQ is 4x plus 10. Find the value of x, then find the measure of OZP and PZQ. Well, I know the whole angle here is 105. The small piece here, 6x minus 5. And then PZQ is 4x plus 10. So once again, this is like the segment addition where we're going to take part plus part equals whole. So I'm going to take the measure of OZP plus the measure of angle PZQ and set it equal to the measure of angle OZQ. So I'll set up the equation accordingly. Well, that means I've got 6x minus 5 plus 4x plus 10 equals 105. Combine like terms, you'll get 10x plus 5 equals 105. You want to subtract 5 from both sides, so you've got 10x equals 100. And so x in this case should be 10. So there's one of our answers. Now we need to find the measure of angle OZP, so we'll plug the 10 in for x in both expressions. So we've got 6 times 10 minus 5, so that's 60 minus 5, which is 55. And then for PZQ, same idea. We'll plug in the x value. We've got 4 times 10 plus 10, so that's 40 plus 10, which gives us 50. So it's a lot like segment addition. Here we have a very similar example. We've got RZT is 110, so we do the whole thing is 110. We also know that RZS is 3S, and that TZS is 8S. What are the measures of RZS and TZS? Well, remember, this is part plus part equals whole, so we're going to add up. So we're going to take the measure of RZS and add it to the measure of TZS and set that equal to the measure of RZT. So go ahead and pause the video, set up your equation, solve for S, and then plug it back in to find the measure of the two angles. When you're ready to check your answers, unpause the video and see what you get. So if you've set this up correctly, you should have 3S plus 8S equals 110, which gives you 11S equals 110, and S should equal 10. So when you plug the value of 10 in for S into both expressions, you get the measure of RZS to equal 30, and the measure of TZS to equal 80.